Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. The topic is Statistical Methods 1 and session is 22. In this session, we are going to deal with the negative binomial distribution concept with the mean, variance and MGF. Also some examples are worked out to understand the concept further. Actually, this is in continuance with the discrete distributions already we are discussing. We have discussed binomial distribution, Poisson distribution and geometric distribution. And this is in continuance with the discrete distributions discussion. The another in line is negative binomial distribution. So, what is a negative binomial distribution? It is exactly opposite to binomial distribution we have already studied. Let the random variable x denote the number of failures, whereas in binomial distribution x was denoting the number of successes. So, here random variable x is going to denote the number of failures preceding the rth success in a sequence of n independent Bernoulli trials. Then x is said to follow negative binomial distribution with parameter r. So, what is the probability mass function of negative binomial distribution? The negative binomial distribution PMF is written as P of x is equal to x is equal to x plus r minus 1 c r minus 1 p power r q power x, where p is denoting the probability of success and q is denoting the probability of failures, and since there are x failures you have q power x, and since there are r successes we have p power r. And taking this kind of combinations in x plus r minus 1 c r minus 1 trials combinations, we get the probability mass function as such, where here x will take the value 0, 1, 2, 3 etc. up to infinity. In other words, if x is the number of trials or if x is the number of trials required to get r successes, then slightly there is a change in probability mass function, but both denotes the same. What is that? P of x is equal to x is x minus 1 c r minus 1 p power r and q power x minus r. X is the number of trials required to get r successes means x minus r trials will definitely result in failures. So, q power x minus r, and since there are r successes, probability p into p into p r times gives you p power r, and the combination is x minus 1 c r minus 1 trials. Okay. In this case, x is the number of trials required to get r successes means at least r trials has to be conducted. So, x will take the values r, r plus 1, r plus 2 etc. up to infinity. So, both the formats of probability mass function of negative binomial distribution is accepted, because many authors have represented in many forms. This is the actual one. Whenever you simplify, you get the other definitions described by other authors. So, x plus r minus 1 c r minus 1 p power r q power x, if x takes the value 0, 1, 2, 3 etc. up to infinity, where x is denoting here the number of failures, and if x is the number of trials required to get r successes, then probability mass function is given by x minus 1 c r minus 1 p power r q power x minus r. Then as usual, the most important three things in any distribution, that is moment generating function, mean, variance. So, these are the works you have to do to for any kind of distribution, that is deriving the MGF and through MGF getting mean and variance, or deriving the mean and variance directly. Okay. So, the MGF of negative binomial distribution using the usual moment generating formula mx of t is equal to expectation of e power tx. But since this is being a discrete distribution, we have to use a summation e power tx into p of x. Okay. And p of x is representing the probability mass function of negative binomial distribution. So, x is equal to 0 to infinity e power tx x plus r minus 1 c r minus 1 p power r q power x. Okay. And this summation is entirely for x. So, p power r is a constant with respect to the summation. We will take p power r outside the summation and club this e power tx with q. So, x plus r minus 1 c r minus 1 q e power t whole power x. Now, keep on substituting the limits. Okay. The limits is x is equal to 0, 1, 2, 3 etc. we have to keep on substituting. First of all, let me substitute x is equal to 0. Before that, x plus r minus 1 c r minus 1 using NCR is equal to NCn minus r. We know that NCR can be written as NCn minus r. Using this property, we can write this as p power r summation x is equal to 0 to infinity x plus r minus 1 c x q e power t whole power x. Now, I expand the summation by substituting the values for x, that is r minus 1 c 0 q e power t whole power 0 plus r minus 1 x plus r minus 1, right. So, 1 plus r minus 1 c 1 q e power t whole power 1. Next is 2 plus r minus 1 c r c 2 q e power t whole square plus etc. up to infinity. Okay. So, this is equal to p power r, the first term is 1 and second term is r c 1 r q e power t whole power 1 plus 2 plus r minus 1 is r plus 1 c 2 q e power t whole square plus etc. up to infinity. Okay. So, this is written as p power r 1 plus r q e power t plus r plus 1 into r by 2 factorial into q e power t whole square plus etc. up to infinity. And this particular summation gives you infinite sum, gives you 1 minus q e power t whole power minus r, which is equal to p by 1 minus q e power t whole power r. But comparing the geometric distribution and negative binomial distribution, negative binomial distribution is about repeating the trials x trials up to r successes are obtained, whereas geometric distribution is repeating the trials till one success has occurred. So, when you put r is equal to 1, we get a geometric distribution from negative binomial distribution. So, this is the moment generating function of negative binomial distribution, whereas when you put r is equal to 1, we get the moment generating function of geometric distribution. Then by uniqueness property, that represents that particular distribution which x follows will represent geometric distribution. So, mx of t for moment generating function for negative binomial distribution is p by 1 minus q e power t whole power r. Through this we have to get the mean and variance. First of all, we will find out a mean, because these three derivations are always important for any kind of distribution. That is why it is being derived for each and every distribution. So, first of all, what is mean? Mean is equal to mu 1 dash is equal to d by dt of mx of t at t is equal to 0. What is our mx of t for negative binomial distribution? It is p by 1 minus q e power t whole power r. Okay. This we have to differentiate and put t is equal to 0. So, how to differentiate that? P power r is constant and I shall write this as 1 minus q e power t whole power minus r. So, minus r into 1 minus q e power t whole power minus r minus 1 into differentiation of inside part minus q e power t. Now, this we have to put t is equal to 0. Putting t is equal to 0 gives you p power r minus r into 1 minus q e power 0 whole power minus r minus 1 into minus q e power 0. Okay. So, p power r minus r 1 minus q whole power minus r minus 1 into minus q. Okay. So, r q into p by 1 minus q whole power r plus 1, this is p power r, right. And then 1 minus q is representing p. So, r q into p power r by p power r plus 1, 1 p power r will get cancelled and the remaining is r q by p. So, we have obtained mean is equal to r q by p. Next, we have to derive the variance. What is variance formula? Variance formula is mu 2 and this is mu 2 dash minus mu 1 dash square. Either in terms of expectation, it is expectation of x square minus expectation of x the whole square, where we have to derive mu 2 dash. Mu 2 dash is d square by dt square of mx of t at t is equal to 0. Mu 2 dash is equal to d square by dt square of mx of t is p by 1 minus q e power t whole power r at t is equal to 0. So, twice differentiating and then substituting t is equal to 0 will give you, in the usual way we can do, will give you r q plus r square q square by p square. I am skipping this proof because it is getting repeated one again and again. 2 times you have to differentiate and then put t is equal to 0. So, this is r cube plus r square q square by p square, this is mu 2 dash. So, what about variance? Variance is mu 2, which is mu 2 dash minus mu 1 dash square. So, r cube plus r square q square by p square minus mu 1 dash is r cube by p whole square. Simplifying, r cube by p square plus r square q square by p square minus r square q square by p square, this gets cancelled and you have only r cube by p square, this is variance. So, consolidating the result, we get a mean is equal to r cube by p and we get variance is equal to r cube by p square. Okay. We have discussed the probability mass function of negative binomial distribution, and then in the usual way and the usual style we have also discussed the moment generating function of negative binomial distribution. Through moment generating function we have derived mean and variance of negative binomial distribution. Let us have a break. Welcome after the break. Earlier to the break we have been discussing about the discrete distribution, that is negative binomial distribution. Probability mass function was discussed, 2 forms of PMFs have been given and also moment generating function, mean and variance have been discussed. Next we shall discuss some examples where you can understand the concept of negative binomial distribution little further. That is, find the expected value and variance of the number of times one must throw a die until the outcome 1 has occurred 4 times. Here nothing is specified that you use negative binomial distribution or you use binomial distribution like that. It will not be specified. Understanding the concept, understanding what has been asked, you have to decide that this particular problem has to be done with negative binomial distribution. So, here see, we are asked to find out expected value. Expected value means mean and variance of the number of times. Number of times one must throw, that is number of trials. One must throw a die means a number of trials until the outcome 1. The outcome 1 is considered as a success when you throw a die for this particular problem. Has occurred 4 times. That is the success of getting 1 in throwing a single die is considered as success. So, getting the success 4 times, what is the number of trials we require? For that particular number of trials, you are asked to find out mean and variance. So, repeating the trials till r successes happens is about negative binomial distribution. So, we have to use negative binomial distribution to find out this particular answer, that is expected value and variance. Solution goes like using negative binomial distribution, shortly NBD. Using negative binomial distribution, the mean is equal to R Q by P and variance, just now we have derived this, right, R Q by P square. What does R stands for? R stands for number of successes. What is considered as success? Success is getting the outcome 1 when you throw a single dice, okay, getting 1 when a die is thrown. P is the probability of success, which is equal to 1 by 6, throwing a die and getting 1. So, out of 6 possibilities 1 has got 1 by 6. So, Q is equal to 5 by 6. What is R here? R is equal to 4. 4 times we should get the success. So, R is equal to 4. So, what is mean answer? All these things gives you mean is equal to R Q by P. What is R? R is 4 and Q is 5 by 6. So, 4 into 5 by 6 by 1 by 6. 6 gets cancelled, answer is 20. So, mean is equal to 20. Variance is R Q by P square. R is 4 into 5 by 6 by 1 by 6 whole square. 6 gets cancelled and answer is 120. So, the expected value and variance of number of times is consolidating the answer. Expected value is equal to 20 and variance is equal to 120. This is the answer we should get. What about the next problem? If a boy is throwing stones at a target, what is the probability that his 10th throw is his 5th hit if the probability of hitting the target at any trial is 1 by 2? That is 10 times he should throw to get 5 successes. 10 times you should throw to get 5 successes. Okay. So, what is the number of trials required to get 5 successes? R is equal to 5. Number of trials required to get 5 successes is 10, right. So, x is equal to 5, then probability of hitting the target is given to be equal to 1 by 2. What is the probability mass function of negative binomial distribution? Negative binomial distribution is P of x is equal to x is x plus r minus 1, x plus r minus 1 C r p power r q power x. In another way, what is the probability in another format? What is the probability that his 10th throw is 5th hit? Here, if x is representing the number of failures, then x is equal to 5. If x is representing the number of trials required to get r successes, to get 5 successes, it here then x is equal to 10. In this format, the probability mass function, if x is representing the number of trials, then I should use the second format of negative binomial distribution, that is x minus 1 c r minus 1 p power r q power x minus r. What is x here? X is 10, we shall use this. Here x is representing number of failures, then x is equal to 5. If x is representing number of trials required to get 5 successes, we shall take x is equal to 10, we will stick on to 1. Okay. So, what is the probability that is 10th hit? So, write p of x is equal to 10 is equal to x minus 1, right. So, 10 minus 1 c r minus 1, r minus 1 is 5 minus 1 into p power r 1 by 2 whole power 5 and q, p is 1 by 2 means q is also 1 by 2 whole power 10 minus 5. Okay. So, this is 9c4 1 by 2 whole power 5 into 1 by 2 whole power 5. 9c4 1 by 2 whole power 10, and by simplification the answer comes to be equal to 0.123. P of x is equal to 10, where I have taken x as the number of trials required to get 5th hit, right. Next type of problem is machine is known to produce 5% defective items. What is the probability that at least 4 items have to be examined in order to get 2 defectives? What is the expected number of examinations required? Solution: a machine is known to produce 5% defective items. So, success is considered as getting defective item. We should always fix up the success, defective item, then only we can talk about the failure. So, in order to produce 5% defective items means p is equal to probability of success is 5 by 100, which is equal to 0.05. What is q? Q is equal to 1 minus p is also equal to 1 minus 0.05 is equal to 0.95. Okay. What is the probability that at least 4 items have to be examined if x is representing the number of trials? Again I will take x is the number of trials required to get r successes. Okay. Then probability mass function is p of x is equal to x is x minus 1 c r minus 1 p power r q power r minus x minus r. Okay. Here you are asked about p of x greater than or equal to 4, where here x will take the values r, r plus 1 etc. up to infinity. So, x is greater than or equal to 4 and 2 defectives, right, 2 defectives. So, r is equal to 2, p already written, p is equal to 0.05 and q is equal to 0.95. Writing all these values here and finding what is p of x greater than or equal to 4. Greater than or equal to 4 means it goes as 4, 5, 6 etc. up to infinity, or else you write 1 minus p of x less than 4, and this is equal to 1 minus x less than 4 means p of x is equal to 0, p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3. But what is x? X is equal to, we will take the values only from r, r plus 1 etc. up to infinity, right, and r is equal to 2. So, therefore, x will take the values only from 2, 3 etc. up to infinity. So, in that p of x greater than or equal to 4, where you have simplified, 1 minus p of x is equal to 0 and x is equal to 1 is ruled out. You will have only 2 and 3, because x is taking the values only from 2 to infinity. So, this is ruled out, we can't get, x is not possible, therefore, you have only 1 minus p of x is equal to 2 and x is equal to 3, because x is taking the values only from 2, 3 etc. up to infinity, where x is representing the number of trials. 1 minus x is equal to 2, 2 means 2 minus 1 c r minus 1, r is also 2, 2 minus 1 p power r, p power r is 0.05 whole power r is 2 and q power 0.95 is q, q power x minus r, right, x minus r is x is 2, r is 2, okay, plus p of x is equal to 3, 3 minus 1 c, 2 minus 1 0.05 whole square 0.95 whole power 3 minus 2. Simplifying this, 1 minus what is in the previous slide, 2 minus 1 c 2 minus 1 is 1, 1 c 1, 0.05 whole square and this is also 1, 3 minus 1 is 2, 2 minus 2 c 1. You have only 0.05 whole square plus 2 c 1, 2 c 1 0.05 whole square into 0.95, and this simplification gives you the answer 0.9976. And in this same question you are asked to find out the expected number of examinations required. The second question, expected number of examinations required is nothing but mean, is nothing but mean, mean is equal to r q by p square. What is r? R is 2, q is 0.95 and p is 0.05 whole square, and the answer comes to be equal to 38. So, based on the discussions about the problems worked out, we can do this exercise. A pediatrician wishes to recruit 5 couples, each of whom is expecting their first child, to participate in a new natural childbirth regimen. If the probability that a randomly selected couple agrees to participate is 0.2, what is probability that at most 15 couples must be asked before 5 are found to agree to participate? So, here you are asked p of x less than or equal to 15, where x is representing the number of trials required to get first child to participate in new childbirth, and r is equal to 5. Proceed and you get the answer. In this session we have worked out about the negative binomial distribution. Probability mass function was discussed, moment generating function mean and variance was discussed. Also some problems have been worked out to understand the concept further. Thank you.